are going to cover today. Okay, and if you have any question related to our demo class or anything that we have done for the last session, if you have any questions, you can ask me. Otherwise, we are good to start. Okay. So let me try to share my screen and then we can start.
Hi, good evening. Actually, today I'm joining. Did I miss something?
No, Deepak. So basically what we have just covered the demo, like a few things, that's all. So we are going to repeat some of the things today as well. So that will be also covered, I believe so. Yeah.
Okay, thank you.
Okay, fine. So let me share my screen and let me know once you see my screen. So, okay. So guys, it will be a whiteboard session first. We'll understand the firewall fundamentals, how exactly the firewall is working, what are the components of the particular firewall. Okay, so what I understand from right now, that all the candidates is having a knowledge about the firewall, is it's a beginning. So we'll start from the scratch itself, like how a firewall is understanding the IP address, how TCP works, all those things will be gonna start. Okay, so first of all, as we understand, the name over here is a firewall. Okay, so what exactly a firewall is? Firewall is nothing but basically a kind of a wall between your organization. For an example, let's say this is your internal network. Okay, and here our firewall sits over here, and here it is a outside world. Okay, so basically the firewall protects against whatever the traffic which is going from your internal organization or inside to our external world. Okay, and also whatever that is coming from outside to inside. Now there is a way to check that particular information, what is going inside and what is going outside. There should be some parameters, right? So I expect everyone that you guys have gone through the OSI model, right? In which layer how a data is getting transferred from one device to another device, right? So we need some details so that we can send one information from one device to another device, right? So where the OSI model comes into the PTC PIP will come into the picture. Okay, so when the firewall started, like when the firewall got invented, okay, so it used to understand few information, and there was a lot of innovation happened. There are a lot of advancement that has happened. Now we are dealing with next gen firewall, right? So we'll try understand from the history past, like how exactly the firewall was made, what was the checking that was done, and then we'll come to next generation firewall, and we'll go on to understand that how, what are the architecture of Palo Alto firewall and all those things. Okay, so now for an example, like if you see these things, like we will be having from layer 7 till layer 1. Okay, we deal with a lot of information, like whenever a PC or a device is sending the traffic to another device, there are so many information which collects, and then it goes through wire and reaches to this PC, right? So now if you try to understand all this information, so with respect to firewall, what exactly it used to do is, we just need to consider right now on layer 3. Okay, so how exactly the firewall will judge whether I need to allow that particular traffic or deny the particular traffic? It is based on the layer 3 information, which is nothing but an IP address. right? So based on the IP address, what is inside and what is outside, we will be creating a policy, something like this. So we'll define a source IP. What is source IP? Source IP is nothing but from where the traffic is originating, right? So for an example, if you want to reach from your home to some location, the source will be your home, right? So source IP will be your internal IP. Okay. So IP address, for an example, I'll just type one IP address 10.1. Now there will be a destination IP address, which can be an external IP address where you want to reach. For example, I wanted to reach to www.google.com, right? So if I want to reach google.com, I have to get an IP address. For an example, the Google IP address is, for an example, 142.250.1.1. Okay, so the source IP and the destination IP. So whenever we need to define some policy on the firewall, we have to use the source IP address. This was the filter parameter we used to do. And if you remember, and if you have configured, this is called as standard ACLs, where we have to define standard or extended, whatever you think of. We used to define, it is based on the IP addresses, not on the source, on the destination. It was on the based of IP addresses. We need to, the firewall needs to understand, basically. Okay, then the extended came into the picture because there was a requirement for port as well. Okay, now I cannot open simply on the IP address. We have to have a IP address as well, sorry, the port number as well. Okay, so this port number is the destination port number, not the source port number. Source port number always be a random port number which will be generated by the client. Okay, now the destination port number is 443. So let's say if I want to reach to google.com, the Google will be listening on port number 443, right? So my destination port number will be 443 and the source port number will be random and will not take that particular port number into consideration. Okay, so after that, there are so many requirement has come, right? So now the requirement is like, I understand that. For an example, I'll give you a scenario. Okay, I have a question for you guys as well. So for an example, let's say this is the PC. Okay, and I am going to internet, for an example, and this is our firewall in between. Okay, and I'm going to google.com. Okay, so my source is, let's say, 192.168.10.1. Okay, my destination is 142.250.1.1, and my source port number will be a random port number, so I'll take 20,480. Okay, destination port number will be 443. Now let's say if I implement this role in this firewall. Okay, so my source is this, my destination is this, my source port number is this, and the destination port number is this. Okay, now if I implement this rule, okay, now tell me when the traffic comes comes from the Google end, whether it will match this particular rule or whether we have to create a new rule.
We have to create a new rule.
You have to create a new rule. Whether, like, if I open this kind of rule, for an example, if I want to create a rule, for an example, okay, so my source will be 142.250.1.1, destination would be opposite 192.168.10.1. I'm not taking NAT into consideration. If you understand NAT, I'm not taking anything on the NAT. Just think about the IP address for now. Okay, source port number will be 443. Okay, destination port number will be 20,480, right? So this is the information which is getting returned from the Google, right? I have to configure this rule. If I configure this kind of rule, whether I'm opening basically a port number for or inside connection, like if somebody wants to connect on port number 20,480, they can connect it, right? Right. So I'm opening a new security threat, right? I'm opening on IP address, which is basically sourced from external IP address, which is not a safe way to configure a security policy, right? Now, to remove this particular issue, we have something called as stateful firewall. Guys, do you know what a stateful firewall is?
It's based on application, what all the application we have to allow.
Okay. Any other one? Anyone?
And it checks entire the packet instead of checking only destination and source IP and port address. It checks entire data, entire packet, which and it contains what it is having inside that packet.
Okay. Anyone?
It will maintain the all entry which can be passed through the traffic from firewall, like a source address, destination address, and port number.
Okay.
And maintain the entry of all of that.
Okay. Yeah. Go on. Yeah, please.
It will keep track of the traffic. I mean to say connection table.
Okay. So what exactly keeps in that particular station?
Like from which source to which destination, particularly using which port. So it will keep an entry of that.
Okay.
And that same traffic can be returned.
Anyone else? Okay, fine.
Hello.
Yeah, go on. Yeah, please.
I want to say that I was late to the meeting, but then can you give me an overview of what you're discussing?
Basically, we are discussing about the firewall fundamentals. So we started how exactly a firewall got introduced in the network. What are the basic checks the firewall was doing in that start when the firewall is invented, and after that now it is moving to a stateful firewall at the stage we are. And I'm just asking what is a stateful firewall. So if you have any idea on that, please let me know.
We no need to create.
Yes, I do have an idea.
Sorry, what was that?
So when one session is taken place, so we no need to create a written policy. So it automatically have that policy.
Correct. So basically what happens is, now let's say we have a source, we have a destination, and we have a source port number, which was 20,480. Okay. Destination port, we have 443, right? So in stateful firewall, what exactly it does is, it's a very intelligent one. The firewall is very intelligent. What exactly it does is, it creates a mirror, it keeps this information, and it creates a mirror ACL for time being. If I say time being, mean that once the connection is finished, it will be removed from the connection table. Meaning that, for an example, I'll tell you from this one. So source port will be 443 and destination port will be 20480. Okay. So now if you see this and if you see this, so basically whenever some user is initiating connection through this firewall, okay, and this the destination is replying on this connection, like to that particular connection, the firewall, what does it do? First time, whenever he receives that particular traffic, he keeps that particular traffic with him, okay, and he keeps this information, and he creates a mirror of that particular policy. So creating mirror means he will be the, whenever the return traffic comes, how the traffic will look like. So he will be expecting a traffic which looks like this. Okay. And it will be created when the session is created. And it allows that particular information or the return traffic, you can say, from this firewall. So basically we don't need to create another or a new policy to allow the return traffic, and we are just allowing the traffic which is initiating from inside to out, which is good, right? But the only thing is, every time whenever a session is created, it will be in the connection table of the stateful firewall. Okay, that is kind of a overhead. Basically it has to be keeping that particular information in the memory. That's fine. Okay, but we are securing that particular network, right? Basically we are securing by accepting the return traffic from the destination. Okay, so in this case what happens is, this rule will be created when the session starts, and this will be removed when the session stops, or once the session ends, whatever you think of, right? So basically what is happening, a new session is created, this session has been this has been added into the connection table. Whenever the return traffic comes, it allows that, and whenever the session ends, it removes from the connection table. Any question, guys?
Yes, sir. Source port is not a fixed one. Destination port is fixed one.
Yes.
If I am requesting something from the cloud and it is not using the same 20480, then how it will communicate?
No. See, 2080 is the source port number. Is a source port number which client has initiated. Client will randomly take one port number. Basically it's a random process that happens into the client PC or whatever device you can think of. It generates based on that particular number. So whenever you create any policy, you always be defining the destination port number. But some of the cases, like very rarely, if you want to create some kind of packets and you want to manually define the port numbers, in that case it's a different case altogether. But usually, or in real-time environment, it will be a random port number. Okay,
In that case, we only create the policies once.
yes.
Out traffic, we will configure the policy for in traffic. If the source and destination IP and port number match, then we need to create the inbound policies.
Yeah, correct. So it's because you will be seeing in a real-time environment, they will be asking two-way communication. So you have to ask the user whether you need a new connection that needs to be initiated from the destination end. Then you need two ways communication. Otherwise, only one policy is needed. One will be allowed, it will be created in the state table, and the return traffic will be allowed. Okay. If they need a new connection needs to be initiated. A new connection meaning that a new session needs to be initiated from the external to internal, and that is required. For that reason, we have to create a new policy. Otherwise, one policy, whatever we have seen the scenario for creating, for going from inside and coming back from outside to inside, this only one policy will work with the help of stateful firewall. Okay. Any other questions, guys?
No.
Yeah, hello. Yeah, I have a question.
Please go on.
Okay. The question I want to ask is not pertaining to what we are learning now, because I'm late. I want to know if it will be possible, or if you will give me the permission to at least record the session, as in whether if I'm done, I can replay and then listen to whatever we've learned so far. Thank you.
I guess this is a recorded session, so you can get it. Maybe it is on YouTube right now. I guess you will be able to watch this.
Okay, very well. Thank you.
What's the page name on YouTube?
What was that?
What's the like page name? Networkings only.
Yeah,
YouTube?
this is on the networking page only. However, I'll share the link. This is only the first class which we are putting on YouTube. Rest classes is on Zoom only. Zoom, and the people who enrolled for the course, they're getting a video access for that.
Yeah, sure.
Okay. So
one more query, sir. I have Googled the firewall is working in layer 7, layer 4, layer 3. That in 3 layers.
Okay. Yes. So I was talking about the layer 3. Now, as we move on to the stateful firewall, it understands about the state, TCP state as well. Okay. TCP state and the port numbers, right? So it also uses the information of layer 4 as well. Okay. So what I mean is, in TCP, if you look at the header, there is a source port number, there is a destination port number, there is a TCP state. So basically, if I talk about a little bit further on the stateful firewall, okay. So TCP, whenever we create a new connection, there will be a TCP handshake, right? Now in TCP handshake, we have something called as SYN. Then we will be expecting SYN and ACK. And then we are expecting ACK. Okay. This is from the initiator. This is from the responder. And this is from the initiator. Okay. Now, what I'm trying to say over here is, now for an example, the firewall, the stateful firewall understands this communication as well. So whenever I send a SYN, the firewall, stateful firewall, will be expecting SYN ACK from the destination. So the stateful firewall will understand the layer 3 information and layer 4 information as well. Okay. Now we'll move further and we'll understand what next generation firewall will understand. Okay. So I'll just rub this off and we'll go further on the firewall. Okay. Now we'll understand about layer 3. We have already understand layer 4. We have understand. Now we'll talk about our data. So basically layer 5, 6, 7 combinedly we will calling as data. Okay. Now, now next gen firewall can understand your data as well. Okay. What does it mean? Like, it understand your application, right? It understand in that application what is going on. For an example, if I talk about YouTube, okay. So in YouTube, we have something called as comment. We have something called as post or upload, whatever you think of. Okay, we are uploading videos, right? We are commenting the videos. So these are the functionality. This is just a little functionality that I'm telling you. There are few more functionality. So I'm just telling you that it also understands, or it also understands what is post, what is upload, what is comment as well. Okay. If I talk about Facebook, right? In Facebook, we have seen lot many things like chat, like games, like videos, right? So in Facebook, the firewall will understand the Facebook. It also understands the chat inside that, games, videos. So you will have a control over layer 7 as well. So how the firewall started, he understand the layer 3, the layer 4, and right now till layer 7. Okay, so why there is a need of to control all this? Now think of, before the user were accessing the websites and the speed was very limited. Then this speed increases, right? The internet speed, it increases. Then we move to YouTube. Then now we are moving towards application, and we have already moved it, right? So if I think about any application, or you just name any kind of application, for an example, social media, we have many. We have Twitter, we have Facebook, and we have lot more, right? If I talk about any messaging app, we are using WhatsApp, Telegram, or something like that, right? And in WhatsApp, we can send images, we can send videos. In Telegram also, we can do same thing, okay? And basically, if I talk about videos, we are using YouTube to see videos, vlogs, and all those things, right? So basically, the user traffics are shifting from website to application. So as per that, the firewall has to be intelligent to control that kind of traffic, right? So that is the reason there is advancement of the firewall. There is advancement, like there is an evolution of user traffic. So that is the reason, this is how the firewall is getting changed to basically protect the traffic which is been going inside of your organization to outside, right? So now in the next gen firewall, we can do all these things, okay? If you have any questions, please let me know. Okay, fine. Now, there are so many ways we are going to understand about the basically what are the devices it offers by Palo Alto Firewall. Okay, we'll try to see that. Before that, we'll try and understand what is the packet flow or a architecture of Palo Alto Firewall. Okay, so as we have understand about the,
Because
yeah,
I have a question.
yeah, go on.
So what's the difference between next generation firewall and threat focused next generation firewall? Are they same or different?
Okay, so basically threat, you are saying about threat focused.
Yes.
Both are the name, whatever you are, maybe you are taking as the name, the threat focused, or if I talk about any other firewalls in the market currently, we are having the same kind of thing. Somebody is asking to allow, Mohit is asking to allow the recording. Really sorry for that. This is recorded on the YouTube. You can watch on the YouTube, Mohit. Okay, so threat prevention is nothing but it provide, even the Palo Alto does provide the threat prevention functionality as well. So if I talk about your question, it is the same what we are having in Palo Alto Firewall or any other firewalls. Okay, because the next generation firewall is having all the solutions, whatever it is possible. Yeah, go on.
Sir, stateful firewall cannot identify types of data.
Stateful firewall
cannot identify the types of data. What next gen firewall can do?
Next generation firewall is equipped with, right now, the Palo, even if I talk about the stateful firewall was a Cisco ASA or Juniper firewalls, right now they are equipped with this feature as well, which is called as next gen firewall. So next gen firewall can do stateful, and they can understand this, but previously they were not able to understand these informations, or they will not be able to filter all these informations. Okay,
got it.
so if we understand the Palo Alto networks, okay, there's something called as single pass architecture. And this is basically a signature concept, or I can say a signature flow, or whatever you think of it by the Palo Alto itself. Okay. Just give me 2 minutes. So guys, whenever the traffic enters into Palo Alto, sorry for this. So guys, whenever the traffic enters into the Palo Alto firewall, what exactly it does is, basically it will not go one by one. Instead, it go simultaneously and process all this and basically send out of the sends that particular traffic out of the firewall. So basically what happens is, the term single pass is something called as, like, whenever the traffic enters into the firewall, okay, a copy will be sent to user ID, a copy will be sent to app ID, a copy will be sent to content ID, so that simultaneously all the engines will perform the tasks and it will be processed and it will be sent out of the firewall. Okay. So basically it doesn't do like this. So for an example, the firewall, the traffic enters into firewall. Okay. It just the policy. Okay. Then it checks the app ID. Then it checks the user ID. Then it checks that particular content ID. And then it moves to that routing and go out of the firewall, something like this. So it takes time, right? Every time the traffic will flow this way. Instead, if I take that particular information and I send a copy to all this, and it will be parallel processing of that particular traffic and sends to routing, and then it sends to outside to which interface I need to send it, and then it will be faster, right? Because if all the engines are working simultaneously, okay, if all the engines are working simultaneously, the work will be faster and it will be optimized way to send the traffic from the processing to outside, right? So this is something called as parallel processing. Okay.
For the large amount of data, is this feasible? Because we are generating huge copies of data.
Sorry, what was that?
For large amount of data, because you are copying each and every packet to all the content ID, app ID, and user ID. Is there any overflow of the data?
No. See, whenever you think of about the high, see, whenever you are sending a traffic from a device to another device, it will not be a 1 GB of data or 2 GB of data. It always be 1500 bytes. That's all. Not more than this. If we are adding something called as some other, it will 36 or 30, I guess. That's all.
What is the MTU?
Yes. Maximum transmission unit. So it will not increase more than that. So always be, and there will be a session already been created for this. Okay. A new, let's say a packet is coming, a session is created, and after that, it will be following the same way. The session is created every time. I need to just check if it is required for content ID to keep some of the data, or app ID to keep some data, to analyze some other things. So in that case, it will be always be traffic will be going to the content ID or app ID. Otherwise, it is not required. Right? And if I talk about a large, still it is going with the chunk of data. That's all. It will not go in a one way. Okay. Now, and we have something.
App ID, sir.
What was that?
App ID.
App ID, yeah.
What is this?
Okay. App ID is nothing but an application identification. Okay. Application identification will go and understand basically in very detailed manner when we have a separate session for that, but I'll give you an overview. So that's what I was telling about the Facebook. So if I want to understand about Facebook, I have to use this engine as called as App ID. So App ID will help you to understand. In the Facebook, we have something called as chat, we have something called as games, we have something called as videos. So it understands the application, how exactly it works basically. So if you want to send that particular, if you are sending the traffic, it analyzes that particular traffic and gives you which has to be allowed or which has not to be allowed as per your policy, what you have defined. Okay. So it
This ID is predefined one.
Sorry, what was that? ID.
This app ID is a predefined one.
Yes, it will be there. You just need to activate in the policy. Okay, the application signatures will be there. What you have to do is you have to create a app ID profile basically, and you have to add it in the policy. Okay.
Hello, sir.
Yeah.
Yeah. So the Palo Alto analyzes the L2, L3 user ID, app ID, and content ID for each packet once the session is established.
Yes, during the establishing of the session, it actually finds all this information from the traffic and checks against it. If you have profile for that, if you don't have that particular content ID or app ID or user ID profile, it will not go for a check for that particular policy.
Okay. So I mean, once the session is established, it will verify all the content in that. So the data transfer takes place. During the data transfer takes place, so it doesn't pre-checks again the user ID, app ID, right?
Yes. So only if you're not activating that, particularly for that particular session, the traffic will not send to that particular app ID engine or content ID engine or user ID engine.
Okay.
Simply it will go check the policy and allow the connection or denies the connection, whatever it is there in the policy.
Okay. For example, if I connected to the YouTube, I'm playing some video. So first it checks the which thing it will check first.
So first it will check the TCP connection what you are having. Then it checks the SSL negotiation what we'll be having from client to machine, and then it recognizes, okay, it is a YouTube, whether I should allow that particular traffic for that particular user or not, and then it denies the traffic.
The app ID will activate.
Yes, if the app ID is activated for that particular traffic.
Okay. Okay, so thank you.
Yeah. And there are so many things you can put a destination of YouTube. You are not going to allow it, something like that. So we'll see when we create a policy or when we are playing with application identification or app ID sessions. We'll do so many combination or commendation for that particular policy, and we'll check how the traffic is working or denying. Okay.
Sure, sir. Thank you.
Okay.
Sir, it will be just the first packet, or each and every packet will be inspected? I mean to say, like every packet, every traffic will be, every data will be inspected, or just the first packet?
It depends on the Palo Alto firewall. If he understands the behavior of that particular application, it's fine. Otherwise, if he is not able to understand, he'll take more data, he'll try to analyze it. What is that? So it keeps on doing that. It depends on the particular pattern of the traffic between user to destination. What kind of traffic that is flowing between user to the server.
Okay, fine. Thank you.
So I want to also know whether if the road time distance.
Hello, you lost in between. You're there? Hello.
Yeah, okay. I've gotten the clarification, so I'm okay.
Okay, fine. Okay. So guys, I have a question for you. What is control plane? What is data plane? Anyone can? No one has any idea what control plane and data plane?
Sir, control plane contains the information of a signaling traffic.
Signaling traffic, meaning?
Yes. Means like a header, source, destination.
Okay, and data plane?
And data is our actual information.
Okay. Anyone?
In control plane, we can make the traffic.
Okay. Somebody has message. Control plane is management traffic.
I think control plane is like IDS, intrusion detection system.
Okay. And data plane is?
I don't know.
Okay, fine. Okay, guys. So just think in a very, very easy way. Okay. So don't mix and match all these things. Okay. I'll give you a very, very simple example of control plane. The traffic which needs to be processed and should be sent a reply for that particular traffic, it is called as control plane, right? And the current data plane is something which will come inside that particular device and go out. So what I mean is, when the traffic is transit, so if something is going, basically which is going through the firewall, it is that is called as data plane. And something which is coming to the firewall and he has to check, he has to process that particular traffic and he needs to reply it, this is called as control plane. So you can think about a PC. Okay. So if I'm initiating a ping traffic, it is going to this PC and the ping reply is coming. So in this scenario, both the PCs are using their control plane because he's crafting a new packet and sending to the destination, and destination is replying to that connection. And if we put a firewall in between, this is for transit traffic, and for firewall it is a data plane. Okay. So let's say
okay, so if I understand you well, meaning that the control plane is basically a protocol, right? Can we term it as a protocol?
It's not a protocol. Basically, control plane is our management area. Basically,
okay.
It's not a protocol.
Okay, sure.
Okay. So what I mean is, let's say if you do SSH, or if you are accessing the firewall through HTTPS connection, meaning that GUI. So you are accessing the firewall, and the firewall is giving you that particular GUI, and you are able, from that particular console, you are creating policy, you are creating routing, or you are configuring profiles. So all these are whatever you are doing. So you are sending the traffic, it is processing, and the firewall is replying to that particular connection. So this is called as control plane, which is nothing but configuration, right? Now logging means that, let's say if I have created a policy, okay, and user is sending some traffic through the firewall, and firewall is denying that particular connection and generating one log. And basically, who is generating the log? The firewall is generating the logs, right? So meaning that the firewall is busy doing that particular information. And he needs to create that particular information. That is the reason it is called as control plane. But in transit traffic, he is not creating anything. He's just processing it, whether the policy is matching or not, whether the rule is matching or not, whether the routing is there or not. So it is just checking whatever configuration is there. It's just checking and allowing that particular connection, right? So that is called as what? Data plane. Okay. And here, when I'm sending the log, the firewall needs to create that particular log and send that particular log to logging server, or he needs to create some kind of reports, generate some reports, and show you via PDF or something like that. So for that reason, the firewall is doing by himself, he is doing all these things. That is the reason it is called as control plane, and which is something which just need to check all this information, or there is a transit traffic which is known as data plane. Any questions, guys? This is very, very important. Okay.
Because 1 second about control plane.
Okay. So control plane, I'll tell you. Control plane another way. To the firewall. To firewall. The traffic will be to firewall. Okay. The data plane is through firewall. To and through. Okay. That's all. Now, if you want, I'll give you a scenario. For an example, let's say a routing protocol that is running. I am running OSPF on Palo Alto firewall. What kind of traffic it will be? If I'm running OSPF, meaning I'm running some routing protocol. So tell me, running OSPF is a control plane traffic or data plane traffic? What exactly it is?
Control plane.
Anyone?
Control plane.
So that means we are configuring the OSPF routing configuration on the firewall, right? So that means it's a control plane, I think.
I'm not configuring it. What I'm doing is I'm activating the OSPF. Now there is, let's say I have, for an example, I have a firewall over here and I have a router over here. Okay. I'm configuring OSPF here. I'm also configuring OSPF here. Okay. So it is building a OSPF neighbor relationship between the firewall and the router. So what kind of traffic it is, I'm just asking.
It's a data plane.
It's a data plane.
Yes.
Anyone else?
Control plane.
Okay. Anyone?
It can be both.
It can be both. Okay.
Because, you know, like if you configure the OSPF, sometimes if you use like the authentication, the firewall has to verify, you know, if we have the same key, something like that. So coming from the router going to the firewall, it may be a data plane, but once the firewall got it, it has to verify if those parameters match.
Okay. Okay. Fine. So I'll tell you. Now, whoever said the control plane is correct. Now I'll tell you why. When we are configuring OSPF, that is control plane, and whoever said it is correct. Now OSPF is running, right? So running, now OSPF, basically the firewall is generating that particular neighbor request or OSPF packets. So who is doing? The firewall is doing it, right? Now there is a communication that is happening between the firewall and the router. So the communication, whatever you are seeing, is what? Is the communication between the firewall and router, and the firewall is generating that kind of traffic, sending to the router is responding to it. So this is control plane, because the traffic or the traffic or OSPF packets need it is created by the firewall itself. But
so is it similar to the sync acknowledged and acknowledged part, similar to that between firewall and router that's happening?
Meaning, I didn't understand that. Since in TCP handshake, is it?
Yeah, like you said that the firewall and the router are communicating. So is it similar to the acknowledgement and sync acknowledgement and then acknowledgement, the three step that you showed us in the previous slide?
That is, see, I'm telling you what kind of traffic the firewall is handling and what kind of traffic the firewall is dealing with. Okay. So for an example, I'll tell you two scenarios. Okay. Let's say this is a router. We have one firewall, make it large. Okay. So this is router and this is firewall. And here we have router. So basically router 1 and router 2, and this is firewall. Now I am building a OSPF between these two firewalls. So I'm configuring OSPF. Okay. Now for this OSPF, who is generating the traffic? Router. Who is responding the traffic? Router. So the firewall is here to just allow the traffic. So right now the OSPF traffic will be the data plane traffic. Okay. And if we consider a firewall and a router, if they are building a OSPF neighbor relationship, in that case, the firewall and the router both are basically using their control plane, and here the control plane is used. Why? Because the firewall is basically
firewall also have to process the data also, no?
Where?
If firewall is working as a router, it will process the data also.
Yeah, it will process. See, this is a transit traffic, right? You are talking about this scenario, right?
No, the second case, sir. First case is clear, but in the second case, it is working as a router. The firewall is working as a router. It is enabling the OSPF, enabling the OSPF protocols. Simultaneously, it is also handling the data traffic, right?
How data traffic will come into the picture? Tell me. How
Sir,
did
the first example, it is working as a transit, means between the two router, firewall is there, and data is going through the firewall.
Yes.
But in the second case, there is one router, one firewall. To go through the firewall. Na?
How it will go through the firewall? It is to the firewall, right? It is not going through the firewall. Firewall is processing that traffic, right? Because we are building a neighbor relationship between the firewall and the router. There is no in between. There is no device itself. It is directly building a OSPF neighborship between the firewall and the router. It is directly, right?
Yeah, but between the firewall, the second case, between the firewall and the router, he will send the first packet. If the router will send the first hello packet, the firewall will answer to that. So data is going to the firewall.
Yes.
That way, you may consider it will be both data plane and control plane.
See, it is going to the firewall. Firewall will read that particular information, and we have already.
Yeah, what I'm trying to explain, I'm not sure if it's clear. Like the OSPF packet, we have hellos, right?
Yes, correct.
So when we try to create the label, the first router, one of those devices will initiate the first hello. Like let's say the router.
Yes.
The router will say, I am 1111. I don't see you, right? And then the firewall via OSPF will reply, okay, I am 222, I see you. Then we can consider that the router initiated the packet going like some data is going through the firewall, and the firewall will reply to that packet.
Correct. That's what I'm talking about. Who will be the destination over here? If I say that OSPF is sending that particular traffic, it will be on the multicast IP address, right? And who is listening on that multicast traffic? The firewall is listening on the multicast traffic. The OSPF negotiation will be happening or not on the IP address. It will be on the multicast address, right? You remember it. Or for an example, I'll just take, so who is catching that particular information? The firewall is catching that particular information and replying to that. So let's say if I'm talking to you and you are replying to me, right? That is, I'm talking to you. So you are listening to my words, and then you are processing that words and you are replying to that so let's say I say hello, then you are replying to me hello. So we are talking to each other, right? This is control plane. Or if somebody is talking to me and is saying, okay, send this message to this guy. So I am becoming the transit. So transit is data. I'm just listening to him and I'm just replying to other guy, like that it is. So the data will come into the picture where I become a middleman, or I can say a transit device. Okay. And if I'm talking
second case, somebody, there will be something behind the firewall. It may be end devices or cloud, and something will be there behind the firewall.
Means I didn't understand. What is that?
For the second case, after firewall, there will be something.
Yeah, there
is nothing in behind firewall. There is no need to firewall, right?
Yeah. See, this is just a way to explain you. This is not a real-time scenario. Okay, I'm just explaining you so that you can understand what is the control plane, what is the data plane. That's all. This is just a way to explain it.
Does it mean that when we are implementing in real-time scenario, it will work in both control plane and data plane?
Yes. It is not a control plane and data plane both. See, you are talking to me, right? You're talking to me right now. Okay. Where you are sending that particular information? You're sending that information to your mic. Mic is processing it. It is going to internet to it is reaching. So who is a transit here? Internet is a transit over here. But you are talking to me, right? So I am replying to you or you are replying to me. We are using our control plane to talking to each other, replying to your words. But who will be the transit over here? The internet is a transit, the Zoom is transit, whatever you think of. Your PC is a transit. That is a transit path, right? So same way, I'm just explaining you the traffic which is going through the firewall, it has considered as a data plane, and which is going to the firewall, it is considered as a data plane, control plane. Why? Because we have to make it different. If something goes wrong, let's say if control plane CPU has problem, some RAM has problem, SSD has problem, or something else has a problem, but still our production traffic which is going through the firewall will still work. That is the reason we have something called as control plane and data plane. Or if something goes wrong at the data plane, our control plane will be working. We'll log into the firewall and we'll check why it is not working. We'll check the data plane. It is not.
How it will work, sir? If OSPF is working on control plane, is our OSPF neighborship is down, how data is flowing?
Yeah, that is the reason. If your control plane is not working, okay, you are talking about OSPF. As you understand right now, that OSPF is our control plane, and if the control plane is not working, how the data plane will work? Okay, now here we have already, let's say, if you try to understand the routing, okay, now whenever the routing happens, there is a routing table which will get generated, which is called as routing table, and from there we have something called as forwarding table, FIB, right? If our routing table itself is not working, how our FIB will work, like how our forwarding will work, right? Now forwarding, in sense, as you have said it correctly over here, okay, if something goes down at the control plane and this routing table goes down and the routing table is not working properly, then the data plane will never work, right? So this is what I wanted to explain you guys, that this is something else and this is something else. Both are basically divided into two parts. This is how the PAN OS is designed basically. Some task will be done by the
control panel is mandatory.
Yes, it will be there in the PAN OS. It is already been divided. Okay, fine. So we have something called as zero trust architect. Okay, zero trust architect, we will need to understand two things over here. One is east and west traffic, and one is south and north traffic. Okay, so east and west traffic is nothing but the traffic which is moving. So for an example, how the internet or how our network look like. So this is as internet. We'll be having a router over here, then we'll be having a firewall, then we'll be having switches. On switches, the PCs will be connected, something like this. Okay, now if if the traffic is moving from this PC to this PC, meaning let's say this is our PC. Okay, if the traffic is moving from this PC to this PC or application to the user, because this is called as east-west way of transit. Okay, and the user is going upward, going to internet. This is called as north-south traffic. Okay, now this is called as zero trust architecture, right? Zero trust architecture is, no matter if you are moving from your internal zone to internal zone, or you are going from internal zone to outside, I am not going to trust. I am going to inspect all the traffic. So in Palo Alto, if you are going from one zone to another zone, no matter if it is inside zone also, it will be inspected. So I'm not going to trust any of the traffic. I need to verify whether the policy exists or not, whether the firewall is allowing that particular connection or not. I have to check each and every traffic. Okay. Now tell me, what is inbound traffic? What is outbound traffic? Whether it's a inbound traffic or it's a inbound traffic. What is that? So the
inbound means
that we can define, sir. No? What will be the inbound, what will be outbound?
How can we define that?
Means,
So here the inbound traffic means the traffic entering into the firewall. And the outbound means the traffic exiting the firewall.
Super. Absolutely correct. The traffic which is going from inside to outside, which is called as outbound, meaning it is going out of the firewall. The traffic which is coming from outside to inside, okay, it is called as inbound traffic. Fine. So every time, whatever the traffic, the way it will be, it can be from internal communication, internal to outside, inbound, outbound, whatever connection it is, it will always be inspected. Okay. Now, what are the firewall?
Sir, 1 second, sir. Can you go back to the last presentation slide? Yeah. So here, sir, 1 second. The next slide. Slide. Yeah, here. So here from the internet zone, for an example, when the traffic is coming from the internet zone to the inside zone. Okay. So here there will be two interfaces, right? On the firewall. For the internet zone, there will be one interface. For the inside zone, there will be another interface, right?
Yes.
So when the traffic is coming from the internet zone and hitting the exit interface of the firewall, so that comes under the inbound.
It will be inbound. If it is coming from internet, it will be inbound.
Okay. And that from the internet zone, it verifies, the firewall verifies the traffic, and it is exiting the traffic, and it is exiting the traffic is exiting from the inside interface going to the internal user. So that traffic comes under the outbound traffic, right?
So you cannot say, basically it will be, you can say in that way as well. But the thing is, like, if somebody is coming, so you will be deciding at the perimeter end, which is going out of your basically organization. Okay. If something is coming from outside, yeah, it is inbound. If it is going out of the firewall, it is outbound. But basically, if you see technically, that is outbound. But from perimeter end, if you try to understand, then the network, it will be an inbound connection. Okay. And if I talk about the traffic which is going from inside to outside, this is we are talking about the perimeter level.
Okay.
At the exit of that particular of your network, which is going to internet. Is it connected to internet? Like that it is.
Okay, sir. Thank you.
Yeah. Okay. Now the firewall, the Palo Alto firewall is really flexible. It can be applicable everywhere. Like it is that particular series, or I can say that kind of firewall you will be finding everywhere. Okay. So they are having in the hardware. If you have on-prem network, you can deploy as a hardware. Okay. If you have in the cloud, you will be dealing with the VM or CN series. CN series where you have Kubernetes. Okay. In VM series, if you have Azure cloud or something like that. Okay. Now it also provides a Prisma cloud as well. So in Prisma cloud, they will provide firewall as a service. So you can take that particular firewall as a service, and you can particular or filters the firewall as per the policy what you are creating in the Prisma. So everywhere the firewall you can deploy. The flexibility, it has a flexible architecture. You can fit that particular firewall in every scenarios.
Sir, Global Protect is a product from Palo Alto, right?
Sorry?
Global Protect.
Global Protect is something else. It is a remote connection.
Hello, sir. So
It is not
VM
coming under software part.
Sorry?
It is not coming under software or cloud services.
It is not coming under a cloud services. Basically, it's a feature of Palo Alto firewall.
Hello, sir. So so you are saying that a VM series, right? That means, so in our network, we are creating an VM, and in that VM, we are installing the Palo Alto OS, right?
Yeah, correct.
So what is CN series, sir? CN
series, you will be, you have Kubernetes, right?
Yeah. Okay. Got it.
You can deploy this as well.
So Prisma means it is similar to cloud, like Azure.
Yes. So we'll be seeing the VM series. We'll be working on VM series to during this sessions, like what we are having. We'll be deploying VM series into 𝐊𝐬𝐳, and we'll be doing our labs.
Okay. What about the Prisma Access, sir?
Prisma Access, we are not going to, because PCNSC never covers this Prisma Access. It has different course to go through.
Okay, sir.
Yeah.
But for VM and real-time hardware, the interface will be the same.
Yeah, it will be same. The only thing that VM doesn't support is a virtual systems. Basically, we'll be dividing the hardware into different virtual systems, which we cannot do in the VM series. Okay. So it depends on what is your scenario for your organization. If it is small, remote, or a network parameters, or a large data center, these are the devices that you guys can go for. So whatever you are seeing in red, it is going to be obsolete now. So it is available. So whatever you are seeing in the blue, those are like on the black, those devices are available. Okay. Now it has a chassis as well. Like if you see over here, the 700 series, it looks like something called as 6500 series, 700 Nexus kind of a series, right? So it has a chassis, it has multi chassis, and you can connect to all the ports where you have mission critical, and the throughput of that particular firewalls will be more, right? So it depends on the requirement what you are having, and accordingly you can put the firewalls. Okay, this is I was telling you about the virtual system. So you can divide a physical firewall into multiple firewalls. Okay, so virtual system 1, virtual system 2. So you can take a physical firewall and you can divide that physical firewall into 2 virtual firewalls. Okay, and you can manage that particular firewall accordingly. So how we do in Cisco ASA, we are making as multi-context. If you have worked on Cisco, right? So same way we will be able to do it in Palo Alto firewall, but that is only possible in physical firewall. Okay.
So how many virtual systems can be created in one physical firewall?
It depends on the that particular model and the of that particular firewall. So if it is 300 or 500 or 700 series, so you will be having 8, 10, 12, something like that. So it depends on that particular model, how much it supports, and you can create that much. Okay. Now, if I talk about the VM series and the capabilities of those models, so it starts with VM50. It's a very, very basic model. And then VM100, VM300, 500, and 700. Okay. Now it has already been given what is the throughput these firewall can give. Okay. What is the dedicated course that is required. Okay. Now we'll be using this one, VM Lite, basically. Whatever firewall that you're seeing in EVNG for lab, it supports only 2 cores and 4 GB of RAM. And also it requires 30 GB of hard disk. Okay. So if you are licensing to VM100, you require this much. If you're going for 300, you require this much, like that it is. So it depends what kind of model you are adopting it. As per that, you have to give that particular CPUs and the RAM and the hard disk to that. So if you are deploying into Azure, you have to choose what is the bandwidth that is required. Okay. And accordingly, you have to give that particular CPUs and the RAM and the hard disk to that particular VM so that the firewall can boot or it perform his basic feature or operation, whatever you think of. Okay.
The features and capabilities will be same for all, other than the throughput.
Throughput and basically, yeah, the sessions will be more. You will be able to, if you are configuring global protect, you will be allocate more users. When you are configuring policy, you can allocate more policies, like that it is.
Okay, so functionalities will be the same.
Functionality will be the same, only the utilization or the resource of that particular features will be more.
Okay, so any difference between VM and the physical device?
Only one difference that I have told, only the virtual systems. Apart from that, there is no difference. The port that you are having, the interface, it will be less in the VM series, but in physical, if you are going for higher model, you will get a lot of ports.
Is it a cost-effective model than physical one?
Yes, yeah. It depends on because physical you have to take care, you have to maintain, you have to keep in some data center and all those things, right? On cloud, you can just go to marketplace of Azure or AWS. You can order it, you can get it. It depends on the users what you are having. Okay, so if you have less users, if you require a small size firewall, then it will be cheaper for you. Like the physical device will be. It depends on the what exactly your operation is, and what is your budget, and what kind of traffic that you want to, what you are expecting in that particular firewall. Accordingly, you can put it. Okay.
Hello, sir. So for an example, there is a VM series 500, right? So, can you go back once?
Okay.
So for this VM series 500, how many virtual systems can be created?
Virtual system cannot create.
Yes. Virtual systems not creating.
Not able to create. You'll not be able to create in VM. It is already a VM virtual.
Okay. Okay, sir.
Okay. Now CN series is like it is, you can integrate with the Kubernetes, and it also, but it is a very, very small kind of a device. Like basically what I'm trying to say is it is not that capable how these firewalls are, like the VM series or the physical firewalls. It's a very small series, but it also provides your visibility, application level, DNS, and all those things. Okay, you know, guys, like the Kubernetes is not that very rigid or high capacity system. They are not, right? So according to that, this CN series has been made to provide security to that particular communication what is happening. Okay.
What actually the Kubernetes are?
Yeah, go on.
What actually mean by Kubernetes?
Kubernetes, you just understand it's a system only. It's a VM, same way, but it will be faster.
Okay.
So I'm not going to the details of Kubernetes right now, but yeah, these are the things. Okay. And next generation also, it has the capabilities to provide the whatever the traffic that is there. So basically we have K2 series for that particular where you have radioactive, like for the mobile connections. In some of the manufacturing area, we'll be putting some kind of radio signals over there. You can configure, you will be having option of K2 series. You can deploy over there. Now all the communication, because those are wireless connectivity, right? Some guys are connecting to that wireless. On that also you can place K2 series as well, and it provides all the functionality what the firewall is providing. So you can put it over there as well. Okay. Yes, I was talking about this firewall or the network or the security as a service. You can take it, and basically your branch or your mobile or your home will be connected. All these things, all these services will be provided to you. Okay, you have to take that particular services, and accordingly it will be processed. So to access your SaaS, to access the public cloud, to access internet, to access your headquarters, the traffic first connect to Prisma, and it will be processed, and then it will go to your internet, public network, SaaS, or headquarters. So you can have that kind of scenarios as well. Okay. Okay, so this is what I wanted to cover today as a firewall fundamentals. Okay, so we have covered the firewall fundamentals. Maybe tomorrow, from tomorrow, we'll understand, we'll log in, what are the options of login, what is the each of the packet flow, start from the end, what is the packet flow, how to log in, what are the options that is available, how you are going to create a users. All these things we'll be covering. Whatever there in the PCNSC course structures, will be covering each of the traffic. So my training, how the training will be going further is like, I'll be having a lecture in sense, I'll be having a theory. Okay, and then we'll go for a practical. Okay, and during the practical time I'll be doing some troubleshooting as well. So you'll be having idea about the practical, you'll be having idea about the theory as well as the practical, and you'll be able to understand the troubleshooting part as well. So all this this is the pattern of my regular classes. It will go like this. Okay, so in case of any questions that you guys are having, maybe
it will be Monday to Friday.
Yes, it will be Monday to Friday.
Sir, every day we will get the link, meeting link to our mail IDs, or do we have to
guys,
check?
you have to join through portal. We are going to upload in the portal. You have to just click on that link and you can join the class.
Okay. What about the recording sessions?
Yeah, you'll get the email tomorrow and you will see the recording also in that particular link.
Okay.
So it will be both a PCNSA and PCNSC, right? Combined, right? Like
Yeah,
first
correct.
we'll be covering like PCNSA, then later on PCNSC, if I'm not wrong.
Right. Right.
Okay. So I have a question on K2 series. Like as you said, like it will be dealing with the radio signals. So it will be normal as um, our wired networks, right? It will be connected beyond any of the internal network or wired network. So the traffic will be yeah, as usual. It will be inspected or does the firewall things. If I'm not wrong, is that same or how it is?
It will be a wireless connection. So basically in larger sites like manufacturing site, if you think of, they're in acres and acres. So if you want to communicate from one factory to another factory or some other connection, so we'll be putting some tower over there to have a connection. For that, if you want to provide that particular security as well, you can provide by putting the K2 series, and it works the same way how a physical or VM series firewall works.
So where exactly this will be placed? Actually, like the communication will be between two towers, as you said. I got that, but like where we will be using this or implementing this K2 series?
So
behind the wired network, right?
Yes, yeah. Yes, yeah.
Okay, thanks.
Because this was like a wonderful content. I just want to make sure to say it.
Thank you so much. Yeah.
And guys, some of the people is asking about the lab. So lab credential we already shared the people who enrolled, so they can see, check the email, and if in case you're not, we'll just approach your counsel. They can help you with the lab details. Okay. So thanks, guys. Tomorrow, same time, 8:30.
So it will be the same timeline. The ending time will be 10 o'clock or 10:30.
10:30 depends on the topic to topic.
Okay.
Yeah.
Thanks. Yeah.
Thanks, guys. Bye-bye.
Thank you.
Thank you, Vikas. Thank you.
Thank you. Good night.
Nick.
Thanks. Bye-bye.